basically you'll get a little bit more information about what the user thought about the product. You'll also get a link to the product's spec sheet on the actual website of the manufacturer. Another thing you get is just some resources at the bottom that are not necessarily specific to that product, but they're just general resources. So if you're going to buy a CD burner, it gives you an idea of what you have to go through to get a CD burner to work in Linux, and maybe that'll help you decide which CD burner you want to choose. Okay, let's go back to Google now. And another website that's out there is linuxhardware.net. Now this website, again, has all sorts of information. It has forums about various devices like audio cards, video cards, USB devices. Linux is getting more USB support every day, so that's a good place to go for if you're trying to find out information about a USB device. Network cards, things like that. Actually, LHD at zdnet.com also had discussion boards on this sort of stuff. And this is a good resource. You know, if you're going to buy something new for your system, it's good to ask people and see what they thought about it. If everybody says, "Oh, that was a pain to install," then you probably shouldn't use it, right? Because if they found it to be a pain, you're probably going to find it to be a pain as well. Now, one thing that linuxhardware.net has on it is Linux-friendly hardware vendors, and from these guys, you can get full systems that have Linux preloaded and that kind of stuff. So let's click on that and see what we get here. Basically, what this says is, full systems. When you see full systems, you'll see you're getting vendors that sell complete Linux systems. And that's kind of nice if you're new to Linux and you just don't want to have to go through and order this sound card and this video card and this network card and this motherboard and put it all together. If that's not your style, if you just want to buy something completely ready-made, then come to this site and look down here and price shop for a new Linux system for yourself. Now let's talk about some more hardware specifics. I know I just showed you that website to look up various hardware and see if it's supported by Linux, but I just want to give you some more information to guide you through this process. So first let's talk about the CPU. Now Linus Torvalds originally wrote Linux on an 8386 processor, and this is an Intel processor. Okay, and you say this 8386, and the whole family of processors after this are compatible with the 8386. There was the 8486, there was the Pentium, there was the Pentium Pro, there was a Pentium MMX there for a while. That was a short-lived one. It was like the multimedia Pentium. And there was all sorts of other ones that came after this. Basically, all of these things are compatible with the 8386, so they'll all run Linux perfectly fine. And practically every version of Linux that's out there is going to run on the Intel chips. Then there's the Intel clone chips. AMD is one vendor, and they have the Athlon chip as well as other chips. And all of these chips, I might as well just throw them in this box too, because these are all Intel compatible, even though they're not manufactured by Intel. So you might ask yourself, why would I want any other processor besides these if these run Linux so well? The only other reason might be some performance reasons. There's the Alpha processor out there that's owned by Compaq now. There's the Spark processor that's owned by Sun. There's the PowerPC processor that was developed by Motorola and IBM. And basically all of these processors are not in the Intel family, and the Alpha processor and the Spark processor in particular are more high-performance processors. If you're doing scientific simulations or real number crunching applications, the Alpha processor and the Spark processor have proven to be faster processors than the Intel family processors. And we're not going to get into the reasons why there, but just know that they're faster for floating point computations, like real number computations instead of integer computations. Okay, so if you're doing that sort of number crunching activity on your workstation, the Alpha and the Spark might be worth the extra money. The Intel and the AMD processors are definitely going to be cheaper than the Alphas and the Sparks, but like I said, these are just a little bit more high performance processors. Then there's network cards. Now, typically when you hook up to the network, you're on the Ethernet. You might be hooked up to either like 10 base T wire, which just means like 10 megabits per second, 10 million bits per second, or you might be hooked up to the newer stuff, which is 100 base T wire, and that's like 100 megabits per second. Okay, so there's the two types of wire you could be hooked up to. You could have two different types of Ethernet cards too. You could have the older ISA cards, which stands for Industry Standard Architecture, okay, or you might have the newer PCI card, which stands for Peripheral Component Interconnect. Now, if you have a choice between these two cards, go for the PCI card because it's got a higher bandwidth than the ISA cards. Especially if you're hooked up to 100 base T wire, ISA tops out at 64 megabits. So even if you were hooked up to the 100 megabit wire, you're not going to get the full bandwidth because ISA is going to be the bottleneck there. The ISA card is only going to go up to 64 megabits. Whereas the PCI card will realize the full potential of the 100 base T wire. Okay, and then otherwise we've got memory and motherboards, and we were talking earlier about the memory options. There's SIM and there's DIMM, which stands for single inline memory module and dual inline memory module. But once you get past that classification, there's tons more classifications for the type of memory. And basically all the modern memory out there spawned off of DRAM, which stands for dynamic RAM. And I'm not going to get into the specifics of what dynamic RAM is versus undynamic RAM. Take some electrical engineering course if you want to see that. That's pretty detailed stuff, and I don't really understand all the different differences between all the various DRAM. There's various DRAM. There's FP DRAM, which stands for fast page DRAM. There's EDO DRAM, which stands for extended data out DRAM. There's DDR DRAM, which is like double data rate DRAM. I mean, there's so many acronyms here and so many types of DRAM. Basically, what you need to know is to go to your motherboard manufacturer's web page, or if you have the manual for your motherboard, open that up, and it'll have in there specifications for what kind of memory module should go into the motherboard, and also what types of DRAM should be plugged in as well. And a newer version of DRAM might come out tomorrow. And who knows what it's going to do, but it might work on your motherboard for a while. It might start giving some errors. The kinds of errors that the RAM's going to give are going to be really fatal errors. They might crash your computer, cause applications to crash. They're going to be practically undetectable. And so stick to your motherboard's manufacturer's recommendations for the type of memory to run on your motherboard. Okay, and you'll just have far more stability, and you'll have less worries about compatibility issues there. And finally, there's video cards. And basically, the most important aspect of a video card is how much memory it has on it. And this memory is independent from the memory we're talking about up here. It's memory that's actually on the video card, and that memory on the video card is specifically for drawing your screen. So ideally, you want your video card to have enough memory so that your complete computer screen can fit in that memory, so every time it refreshes, it's just refreshing from the video card's memory. And if you have 8 megabytes of memory in a video card, you're set. I mean, you've got enough memory for like 32-bit color and a large resolution screen, and all that will still fit in 8 megabytes of memory. And basically everything else that we didn't mention here, like keyboards and mouse and sound cards and who knows what else, is pretty much supported by Linux. For super specialized things like scanners or USB devices or I don't know, video acquisition boards or whatever you've got, look on those web pages that I pointed you to find out specifically if those devices are supported by Linux. Talking about hardware compatibility reminds me that in the last video I told you that I would show you how to determine your Linux kernel version number. So we'll do that now, and while we're doing that we'll also talk about library version numbers and that kind of stuff. So the easiest way to determine your kernel version number is just to type kernel version at the command line, and you do that and you get the version 2 and the major version number 4. So that gives you the basic information. If you need to know that third digit too, that minor version number, then what you can do is you can do a listing on the /boot directory, and in the /boot directory is the Linux kernel, and it's right there. It's called VM Linus, and it has these numbers after it. And the numbers after it, 2.4.7, is the version number of your Linux kernel. Now the reason you might need to know this is just because there's some sort of compatibility issue that you're trying to resolve. In the Linux 2.2.18 kernel, I think that was the first Linux kernel that had USB support. So you would know if you wanted to hook up USB devices to your system and you had an older kernel than 2.2.18, like 2.2.10 or something, you would have to upgrade your kernel so that you could have USB support. That's the kind of stuff you'll learn by looking at the kernel version number. Now for libraries, one of the places you can look is in the /lib directory. In the /lib directory is a whole bunch of files. We'll just do an ls, and there's going to be a whole bunch of files that'll scroll off the screen. We'll just look at some of them, and then we'll talk about how to see all of them in a second. So we do an ls on this directory, and you can see there's a whole bunch of files here. Here's the libc libraries, and you can see it's version 2.2.4. This library is used by a lot of different software in your system, and there's the version number. If you wanted to see everything in this directory, what you can do is you can do an ls, and then you can pipe it through the more command. Now this vertical bar is called a pipe because the output of the ls command is flowing into the input of the more command. All right, and basically, you know what the more command does. Remember, it just displays text files one page at a time. All right, and we know what the ls command does. It displays all this directory information. So what's going to happen here?